we want to compute the limit as x goes to infinity of 3 plus 2x squared minus x cubed all over 5x cubed minus 2x minus 4. This function is called a rational function. It is a ratio of polynomials. And when we calculate the limit as x goes to infinity, we're looking for horizontal asymptote behavior. If the limit as x goes to infinity of f of x is equal to L, then the line, the horizontal line, y equals L, is a horizontal asymptote for the graph of f of x. And this is on the right end. We can make a similar statement about x going to negative infinity. That will also give you a horizontal asymptote on the left end. So the technique is to take advantage of the fact that the limit as x goes to infinity of some number divided by a power of x is 0. The form a over infinity, where a is just some number in a limit, is 0. Think about 1 over, take a to be 1, and the quantity that's going to infinity, that means it's becoming very large. 1 over, say, a million, that is a tiny little fraction, 0.000001. So when the denominator goes to infinity and the numerator is just some number, then the fraction will head towards 0. So the trick in this type of problem is to create fractions of this form, and we will do so by factoring out the highest power of x in each of the polynomials. These polynomials, top and bottom, are both degree 3. They're cubic polynomials, degree 3. So we will factor x cubed from the top and the bottom polynomials. So when we factor out x cubed, the 3 in the front will become 3 over x cubed. Notice that if we multiply that back together, we will get 3. The 2x squared will become 2 over x, using the fact that x cubed divided by x is x squared. So if we multiply these together, we'll have an x cubed on the top and an x on the bottom, and that will give us 2x squared, which is this. And then we just have minus 1. And on the bottom, it'll be 5 minus 2 over x squared minus 4 over x cubed. The minus 2x is the same, this term here, minus 2x, is the same as minus 2x cubed over x squared. X cubed over x squared is x. So if we factor out the x cubed, we're left with negative 2 over x squared. Okay, now we can cancel the x cubes. X cubed over x cubed is 1. I'll write it all out, although sometimes people just prefer to cross them out and then ignore the expression. I'll write it out. So now look at that numerator. In that numerator, we have 2 fractions of this form, and their limits as x goes to infinity are both 0. And on the bottom, we also have 2 such fractions whose limits are both 0. So the final answer is 0 plus 0 minus 1 divided by 5 minus 0 minus 0. Again, the limit as x goes to infinity of this fraction, for example, would become 4 over infinity, and that's 0. And the final answer is negative 1/5. So that means the line y equals negative 1/5, that's a horizontal line, is a horizontal asymptote for our function, I'll just write y equals f of x. This is our f of x, the whole thing. And this is on the right end. You can have a horizontal asymptote on either end. So this is the right end because x is heading towards plus infinity.